So welcome everyone to this video. We have this question. Uh, Basically, if the mass of an electron is m and c is the speed of light, uh, then what is the ratio of the wavelength of photon energy E to that of electron of the same energy? So basically, we have some kind of energy E for the photon, and we have to take the ratio of its wavelength to that of the de Broglie wavelength of the electron having the same energy. So we know that the energy for a photon can be written as E is equal to Pc, where P is the momentum of the photon. Right. So let's say the wavelength of the photon is lambda. So this becomes h upon lambda photon into speed of light c. Same kind of expression can we write for the electron? The answer is yes. For electron, let's say lambda is the wavelength. It is equal to h by p of the electron. So h is simply Planck's constant and Pe can be written as 2 times mass of the electron, which is given to us, and the energy of the electron, which is E. So from this we can find what is the ratio. If we substitute the value of E here, probably we can find, or yes, from here we can write wavelength of photon is equal to hc by E. So if we divide the ratio of photon to that of the electron, lambda p divided by lambda e. And since both of them have the same energy, we have put the same value of E here as well as here. So wavelength of the photon, that is hc by. So this is option first, I think. So thank you for joining and have a good day.